Hey everyone, welcome back. This is part 8 of the processing tutorial. So let's go ahead and recap what we did last time. We used these 4 variables up here and these if statements in order to get this ball bouncing off the side of the screen. Okay, so we have the x and the y, which control the location, the x delta and the y delta, which control the amount of pixels or the number of pixels each time the draw loop is called that the ball is moved in both the x and the y direction. So when it hits these walls, this will change based on the direction the ball is going. So if it hits this wall, the x delta is now a -2. When it hits this wall, the x delta is now a +2. And when it hits the top wall, the y delta becomes positive 2.5, and when it hits the bottom, the y delta becomes -2.5. And we switch that delta value by using these if statements. And to review the vocab, each one of these if statements computes some Boolean expression, and it uses that Boolean expression to know if it should run the code inside of its braces or not. So inside this curly brace and this curly brace. If this is true in here, it will run this code in here. And same with this one down here. And so this is a Boolean expression right here, this x greater than width minus 10, because it can evaluate to true or to false. And so is this one over here. It's also a true or false value. And then this OR combines this and this to make a third true or false value. So this one and this one, if they either of these are true, then this whole statement will be true, and this value will have its sign switched. So x delta will switch and go the opposite direction. Now, the objective in this tutorial and the next one is to get more balls on the screen. And we have to actually learn 2 concepts to be able to do that. We have to learn what an array is, and we have to learn what for loops are. Now technically we could do it with just arrays, but that's going to end up creating way too many variables for us. So what we want to do is we want to learn both of those, both a looping and an array, so we can create nice looking code that is a little bit more adjustable than if I just showed you arrays and set it up that way. So the idea of looping is already familiar to us, because in the program loop, draw is being called. So in our case, 60 times per second, or at least it's trying to get to 60 times per second. But the for loop I'm going to show you in just a minute is a loop that we make, and we get to control how many times it goes. So I've actually set up a second project, a nice small one here for us, so we can play with loops and arrays to begin with without actually having to deal with all this code and trying to understand it in this context. So first thing I'm going to do is just going to show you what this does. And all this does right now is create a black background with a white ball here, a white ellipse. And most of the stuff we're about to see is going to be running down here. And this is with all the for loop stuff. So I'm going to show you how a for loop is made to begin with. So it's actually quite simple. We type for, and then just like an if statement, it has stuff we're going to put in here, and it has this, so a starting and an ending, and all the code will run between this brace and this brace. Now the inside of a for loop is actually a little bit more complicated, or it can be at least, than an if statement, and it actually involves 3 separate expressions. So the first expression is going to use a new type of variable, and it's called an int, or an integer, which can be either a negative or positive whole number, so no decimals. And usually we call this I or j or k or something, just usually a one letter variable for ease of use. So int I equals 0. That means we're going to create a variable named I. And this variable only has scope within the starting and ending brace here. So after this and before this, I can't use I. Next, what we're going to say is I is less than a certain value. So in my case, I'm just going to put 5 here. And then I'm going to put at the end I equals I plus 1. So what this says here is in this first one, create a variable I, and in the second expression here, it says do this loop while I is less than 5. And then for every time I go through the loop, do this computation, add 1 to I. Now it won't run this one, and it won't look at this actually until I've gone through the loop. Well, it could look at this, but it won't run this until I've gone through the loop one time. So let's actually test that, and we're just gonna print the value of I. So what's gonna happen is it's gonna start at 0, and it's gonna check first if this loop can even be run. So if I put let's say I put 0 here and run this, you notice nothing prints out because 0 is not less than 0. So this is false, which means this won't actually work. If I put 1 here, it's going to print out just the 0. So it's going to say I is equal to 0. First check if I can do the loop. Yes, 0 is less than 1, so that's true. Go through the loop one time, then add the plus 1. So I equals, which in case is 0. So 0 plus 1 is 1. Then check this one again. Okay, so it's a little bit confusing the order it's doing it in, because this actually gets done down here. After we've gone through the loop once, it gets to this and then it adds. Then it comes back up and it checks this again. It only runs this one time. This is just only the initializer. This is checked every single time the loop goes, and this is actually done at the end of the for loop. So after all the stuff in the for loop runs, then we add 1. So if I bump this up to 5, it's going to print 0, 1, 2, 3, and 4. So I run this, and I get 0, 1, 2, 3, and 4. Alright, so the syntax is a little weird, and you're probably going to have to look at this or write it down, or just copy it again and again until you remember it by heart. Now, there is a shortcut. Instead of saying I equals I plus 1, which I'm going to show you in just a minute, but I want to show you that you don't have to always add by 1. I could add by 2, and in this case, it'll get 0, 2, and 4. And then when I becomes 6, this is no longer true. 6 is not less than 5, so it's false. So it exits the for loop and starts running code down here. All right. So for loops can go up or they can go down. I could even do this while I is greater than 0, and then I can say I minus 1, and that's going to give me 5, 4, 3, 2, 1. Alright, so this calculation over here can be adding, subtracting, multiplying, or dividing. You just need to make sure that whatever you do, it doesn't become something called an infinite loop. And an infinite loop can happen very easily if you're not careful. So let me show you what an infinite loop might look like. This right here would be an infinite loop. Because I starts at 0, this is going to run while I is less than 5. And what I'm doing each time is actually subtracting 1. So I starts at 0, and then it subtracts and becomes -1. And then it becomes -2 and -3 and -4. And it's just going to keep running because I is always less than 5. And what happens when you do that is eventually, well, it's going to take a long time, but eventually your program will crash because it'll try to have too big of an integer that the computer can't store. And that's going to take you a long time. Okay, so watch out for infinite loops. Try not to get into one. If your code, for some reason, if you see processing is just stopping running, if everything's hanging, meaning things are just coming out here, maybe you're printing a lot of stuff, or nothing's happening on your screen and this loop is just continually going, it's an infinite loop, and you're going to want to check your for loop for that. Alright, so why do we need this if we're going to draw a bunch of ellipses? Well, it makes sense if we have a loop that we could use this loop also to draw a bunch of things. So let's test this, and I'm actually going to use this, and I'm going to draw I, and I'm going to put I, and this time I'll put 50, 50 here. And I'm going to make my I less than 100, and I'm going to add by 20. Okay, so think about what this is going to do. I starts at 0. We're going to keep doing this while I is less than 100, and we are counting by 20s. So the first coordinate is going to be 0, 0. The second coordinate I will have added 20, so it'll be 20, 20. And then it'll add another 20, so it'll be 40, 40. And then it'll be 60, 60. So if I run this, what I'm going to get is this. So as you can see, one is kind of right there, and then this one moves out to 20, 20, and then 40, 40, then 60, 60, and then 80, 80. Okay. Now, you can also do like less than and equal to. So this time it's going to print one more. So now I get one more at 100 and 100, and that's just fine. And the original one is still printing here from up here, or drawing from there. But what we want to do is we want to be able to kind of save the location of our ellipses and draw a whole bunch of them and move them around the screen, which means we need more than just a for loop. What we actually need is a way to store more x's inside here. So let's go to the concept now of arrays, and we'll look at that. So if I told you I want you to draw multiple ellipses on the screen, you're probably going to say, well, I can do that. I have an x and a y here, and this one's already being drawn. What I'll do if you say draw 3 ellipses is I'll just do this. I'll just say float x1, float x2, float x3 equals 10, and then I'll also do the same thing for y. Float y1 is equal to 100 maybe, float y2 is equal to 50. Let's make this different actually, let's make it 150. And let's say float y3 is equal to 70. Alright, so you do that, and then what you do is you just copy your ellipse onto a couple more lines. And you're going to be pretty happy with that because you're going to get those 3 ellipses. And you say, ha, I've finished. I drew 3 ellipses, no problem. Alright, and if we do this, run, and look, 3 ellipses. Okay, but now what if I asked you to draw 1,000 ellipses? Are you really going to want to write 1,000 x variables and 1,000 y variables? Probably not. Thankfully, there's a much shorter way to do it, and that uses arrays. And what I'm going to do is just turn these and these into an array, and then we'll use our loop to draw the ellipses back out. So right now, let's take these x's and first change them. So I'm going to go back to using the variable x, but between the variable and the float type, I'm going to put these square brackets. And what these square brackets mean is the variable coming after it is of a type float, but it is a float array. And to make a float array, I'm going to use these curly brackets. So you notice we're using these curly brackets for quite a lot of things, for enclosing our functions and enclosing our if blocks and our for loops and things like that. Now we're using them to declare an array. So I do this and that. Now this is what you call hard coding in the array. You're initializing the array, and you're not really, like, the values will always be this. We're not randomly creating the values, but later on we'll randomly create these, so the balls will be different each time. Alright, so I'm going to delete these because I no longer need these variables because now they're all stored under x. And I'm going to do the same thing with y. So I'm going to change this to y, and I'm going to change these values to be the same as this. And then I can just delete these. Alright, so that's pretty good. Now I've got these values stored in here. But how do I get these values? You might be thinking, well, I can just get rid of these x1s now, go back to this, and good, this is x and this is y, so it's going to draw all my ellipses, right? Well, it actually won't, because the ellipse function, or method, they say method, but and I'll remember I'm going to get to that in the section on object-oriented programming, but I'm just going to call them functions for now, that these floats, it's expecting 4 floating type variables in here. But this is saying that I have not floats, but float, and these are the square brackets signifying it's an array. So I'm saying float, float, and then 2 integer variables. So it's saying these are the things it's complaining about. It doesn't want those. It wants a float, not a float array. So what I could do is I could access them like this. I could say, yeah, let's do the first one there. and I could then take this, and I can run this, and it draws one of my ellipses. That's because this is actually saying this one. Now you're probably saying, wait a second, you put 1 here, shouldn't that be 100 and 100? Well, in programming, this is actually 0. So I'm going to jump over now to a short example. I'm going to take these numbers, 150, 10. Okay, 150 and 10. So in memory, this is what your array looks like. There are these 3 indexes, and indexes is the address or like the location that the value is stored at. And so this is my array X, and it has 3 indexes in 3 places in memory for 3 values. And another word for these will be elements. So these 3 elements in here, and I'm going to use value and element interchangeably. So at the 0 index, there's a value of 100. At the 1 index, there's a value of 50, and so on. So to access something or to change it, you type the name, and that's what I did here. I said X, and then I said get me whatever is at index 1. So I said get whatever at index 1, which is 50, and it would draw the value at 50. Okay, so for X. Now, array name, your index value inside these square brackets, and if you write equals value, it'll put this in here. So let's practice that. Say I want to change this to be 250. I would do index 1 is equal to 250. And that'll change the value in here to 250. Or if I wanted to say 2 is equal to 5, then it would put 5 inside here, and then this would now be 5. So you can kind of think of an array as a big long list of boxes. Each box has a number on it. That number is the index, and every box just has one thing of whatever type you said. And we said floating points, so all of these floating points, and each one has this address. And if you want to go to the address or the index, you just put the index in here, and then you can either get the value out, or if you're making an assignment, you can put something new inside that box. All right, does that make sense? Now, if you want to access something outside, you're going to get an error. So let's say you accidentally type 4 and you try to put 5 inside 4. Well, this array doesn't have any address 3 or 4. So it's going to give you an error, and it's going to say array out of bounds, or it's going to crash in some way. So for example, if I came back here and I typed 5, it's going to say array out of bounds exception, and it gives you the number, the index you're trying to get to that isn't correct. So I'm trying to go in the array X, and I'm looking for 0, 1, 2, 3, 4, 5, some number that should be out here, and it's not. So it gives me this array out of bounds. And you'll probably get that error quite a bit when you first start using arrays, and that's all right. Just follow what it says down here, look for the number, see where you're accessing it incorrectly. All right, so this hopefully makes sense to you. If you want to look on the website at the supplementary material, there's going to be another link to more information about declaring arrays. And in the next lesson, we're going to do more as well. All right, so let's actually use our array now to draw some ellipses. So what I want to do is I'm going to take this and I'm going to put it inside here. Then each one of these arrays has 3 elements. And these right here, this at index 0 and index 0, that's my first ellipse. So it's kind of like if I just wrote 100 and 100, but alternatively I could write x0 and y0, and that would give me this one. And that's gonna this time it's gonna loop through, and it'll just draw it all at the same place. So now we have 3 things in here, and we want to access index 0, index 1, and index 2 of each one of these. So we need to change our loop to only go 3 times. So it starts at 0, and we want to make it go while it's less than 3, because if we make it equal to 3, it'll actually count 3 as an index, and there is no index 3. The highest index here is 2. So we want to count not by 20s, but by 1s. So we start at 0, it checks, is 0 less than 3, and then it says yes it is, so it comes in here and runs this. And we don't want to use 0 here, we want to use actually I, because I is going to count each time up 1, 0, 1, 2. So 0, 1, 2, and that'll print out our 3 ellipses all at the same time. And every time it ends the loop, or goes to the end of the loop, it comes up here and it adds +1. So if we run this, we will get our 3 ellipses drawn all at these locations. So notice 100, 100 is right here, 50 and 150 is here, and 10 over and down 70 is right there. And if we want to print more, what we can do is we can just add more pairs to our list here. So if I add 2 more pairs, 300, I now have 5 elements, so I can change this to be 5, and I can run this, and it will print out 5 ellipses. And you can add as many as you want. Alright, and we're going to learn a new way later to add some stuff to these, but right now we're just gonna write values in ourselves. Alright, I told you one more thing about this, and I told you I'd show you a shortcut. There is a shortcut for adding 1 to integers, and it works with integers, so don't try to use this with something else, but I mean you can, it's just not going to work. Instead of saying I equals I plus 1, if we just want to add by 1, we can use a plus plus. So this is the same thing as writing I equals I plus 1. And if I run this, I still get my 5 ellipses. Alright? So you're probably looking at this and you're saying, okay, well this makes sense. I can pop back over to my code now and try to modify things and maybe print out more ellipses. And we're going to do that in the next lesson. So come back for lesson 9, and we're going to use this code, and we're going to come back to this code. We're going to put them all together. We're going to add another array for x delta and y delta, and we're actually going to get as many balls as we want bouncing around the screen. Alright, and as always, if you have some questions or concerns or just any general comments, please leave them either on my website or in the YouTube comments. Alright, thank you, and see you next lesson.